Let's say that you're a moving thing that needs to get from point A to point B, and you want to know how many steps it takes to get there. I'm going to help you out by marking the length of your distance and then dividing that into tiny steps so you can gauge how close you are to B. How many steps would I need to make? The famous Greek philosopher Zeno of Elea considered this in a problem he referred to as the dichotomy paradox. He stated that in order for any moving thing to achieve a journey, it must first reach the halfway point. Of course, to reach the halfway point, it would have to cross half of that half distance, and so on and so forth ad infinitum. It just gets out into infinitely smaller steps. Therefore, motion is not possible, and in fact, is a big fat hoax. Since in this scenario you are infinitesimally tiny, Zeno's paradox may pose some concern. In real life, humans don't have to consider these sorts of things because we take finite steps across finite distances in a finite amount of time. But Zeno wouldn't be satisfied until Aristotle tried his hand at solving this paradox with his concepts of potential and actual infinity. Let's say you want to check into a hotel and you've booked room 1. However, another client is already in room 1, so all the clients in the hotel have to be moved from the current room to the next room. Will the hotel be able to accommodate everybody? A potentially infinite number of rooms means that for every client that has to move, a new room pops up for them, and the number of new rooms added cannot be exhausted or completed. So there's always an available room, no matter the number of clients. An actually infinite number of rooms means that there's already a set number of rooms in the hotel, so a new one can just magically pop up out of nowhere, and a new client cannot be accommodated, as all rooms have been filled. Therefore, according to Aristotle, the reason we as moving things are capable of getting anywhere is due to this concept of potential infinity. Now we can see how well the concept of potential infinity answers our original question. How many steps do we need to take? We know that potential infinity requires a number of steps that cannot be exhausted. So how can we reconcile this with the journey from point A to point B, which is a complete distance? Well, for an object to have motion, it needs to change its position over time. You have your starting position and your ending position, but we also need to take into account your current position. If the distance between your current position and B gets smaller and smaller over time, it doesn't matter how many steps you take, at some point you will reach B. But this is where it gets tricky. This does not really prove that motion exists, which is the major hangup. Why? Because if you introduce a new variable, time, if the time taken for each step is the same, then we can say that it takes an infinite amount of time to reach B, which literally puts us back at square one, unable to move. Why does this happen? This problem is not a matter of infinity, it's a matter of motion, which cannot be proved mathematically. Aristotle's solution may have helped at the time, but it was really just a clever loophole. The real answer lies in Newton's first law. An object can cover any distance in a finite time if it travels undisturbed at a constant speed. Using physics, you can reach your destination, and Zeno's paradox is conclusively solved.